Ever wondered how to best service devices like analog to digital converters and digital to analog converters that only need attention every few hours? Well, the answer lies in the method used to interact with these devices. There are three main methods you can choose from: polling, interrupt-driven I/O transfer, and DMA-based I/O transfer. But which one is the most suitable in this case? Let's delve deeper into each of these methods. Polling, as the name suggests, involves the CPU constantly checking the status of a device to see if it requires servicing. While it's a simple approach to implement, it's not very efficient, particularly in a scenario where devices need servicing only once every few hours. The CPU's energy is wasted in continuous checks, leaving less time for other important tasks, so polling might not be the best solution here. Now consider the interrupt-driven I/O transfer method. In this method, the device sends a signal, an interrupt, to the CPU when it needs servicing. This way, the CPU can carry on with other tasks and only attend to the device when necessary. Given the intermittent servicing requirement, this method maximizes CPU efficiency, making it a perfect fit for our scenario. And then there's the DMA-based I/O transfer method. This method allows devices to read from and write to memory without continuous CPU intervention. It's a great method for transferring large blocks of data, reducing the CPU load significantly. However, for devices that need attention only every few hours, this might be an overkill. It's more complex to implement and might not offer significant benefits over the interrupt-driven method, considering the infrequent data transfer needs. So to sum it up, when servicing devices like ADC and DAC that require attention only every few hours, the interrupt-driven I/O transfer method comes out on top. It strikes the right balance by reducing CPU waste and handling device service requests efficiently when they occur. It avoids the continuous CPU cycle consumption seen in polling and the unnecessary complexity of DMA for this scenario, making it the optimal choice. So, the next time you're faced with servicing switch devices, you know which method to opt for.